Okay, this is test 3 review. There are 30 questions. Question number 1. What's wrong with the following statement? Because the digits 0, 1, 2, 3 up to 9 are the normal results from lottery drawing, such randomly selected number have a normal distribution. Okay, so if you try to pick any number randomly, the chances of getting any number is equal 1 out of 10 because there are 10 different digits. So instead of normal distribution, it's a uniform distribution. So choose the option where it says uniform distribution. This one, since the probability of each digit being selected is equal. So if you are solving uniformly distribution problem, there is a calculator you can use in StatCrunch as well. For example, problem like this, the waiting times between a subway departure schedule and an arrival of a passenger are uniformly distributed between 0 and 5 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 3.25 minutes. So to solve a problem like this, go here, open the StatCrunch, and then go to the stat calculator, and down here there is a uniform calculator, uniform distribution calculator. The lower limit here in this case is 0 minute, and then upper limit is 5 minute. And then we would like to find out the waiting time greater than 3.25 minutes. That if you input those information and compute, it's going to give you the area under the curve from 3.25 to the right side, and that is 0.35. So that's the probability, 0.35. Find the area of the stated region. The graph depicts the standard normal distribution with mean 0 and standard deviation 1. So this is the G-score you have given. Either you can use this table. I'm not going to use the table, and I suggest you to use StatCrunch. That would be more easy and efficient. So in this case, you would like to find out the area under the curve for the G-score 0.18. So go to the stat, go to the normal distribution calculator. So since this is the G-score, so the mean is 0 and standard deviation is 1. We would like to find out the probability for the value which is less than 0.18. So less than means it's the left side, and if you hit compute, that will give you similar type of the graph here, and then probability is 0.5714. If you round it to the 4 decimal place, that probability and the area under the curve, that is same thing. So the answer is 0.5714. 0.5714. Okay, this is a very similar question, but this time instead of less than, because you can see that the area to the right, so you have to choose greater than, and then value is negative 0.84, and if you hit compute, that will give you the area under the curve to the right side of this G-score, which is 0.7995. 0.7995. The area in between these two G-score can also be calculated using the same calculator, but this time you have to choose between, and then the value is from negative 0.91 to positive 1.24, and that's 0.7111. So if you round it to the 4 decimal place, 0.7111. That's the area between these two G-score. So here the area under the curve to the left of this G-score is given, which is 0.9719. We are interested to find the G-score, so we can use the same StatCrunch, but this time just standard one, and then sign is less than. We don't know what is the value of G-score, so this box would be empty here. And on the right side, we know the area is 0.9719. That's the area, and that will give us the G-score, which is 1.90. If you round it to the 2 decimal place, it's 1.91. So we would like to find out the G-score for the area under the curve where the area is this. So this time again same, but this is greater than sign, and we don't know the z-score, so we have to make this box, the middle one, empty. And on the right side we know the area, which is 0.7517. So that is actually negative 0.67, and that makes sense because the z-score is left to the the center. So 0.6798. So if you round it to the two decimal place, it's a 0.68, negative 0.68. Assume the reading on thermometers are normally distributed with the mean 0 degree centigrade and standard deviation is 1 degree centigrade. Find the probability that a randomly selected thermometer reads between negative 1.69 and negative 0.27 and draw a sketch of the region. So keep in mind it's in between these two values, so it's supposed to be the first one, and we need to find the area under the curve, which will give us the probability. And you can do that by using the table, which I would not recommend. So I would just recommend you to go and use a StatCrunch and just use a between calculator and just plug the value, which is negative 1.69 to negative 0.27, and that will be the area 0.34. If you round it to the four decimal place, it's a 0.3481. 0.3481. Remember, the area under the curve also represents the probability. That's the same thing. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with the mean 0 and standard deviation 1. Draw a graph and find the bone density test score that can be used as cutoff values separating the lowest 3%. So area under the curve to the left is 0.03 and highest 3%. The area under the curve to the right is 0.03. So it's a left and right. So this is the right graph, left side and right side. And now to find the value, you can go back here and then you can find it one by one. So what do? You use a standard calculator and then standard one. So you want to find out the value for less than something, which gives you 3% to the left side. 3% to the left side. So you want this value, which is negative 1.88. So if you round it to the two decimal, it's a negative 1.88. That's the first value. And for the second value, instead of you here less than, now you need to change it to the greater than. You want to find out the value here such that the area under the curve to the right of that value is 3%, which is 1.88. Again, that's a positive this time. So comma 1.88. Okay, which of the following groups of the terms can be used interchangeably when working with the normal distribution? So when we work with the normal distribution, area, probabilities, and relative frequency. Relative frequency, that is also probability. So they represents the same thing. The weights of the chocolates in Horsey Kisses are normally distributed with the mean 4.5338 gram and standard deviation 0.1039 gram. Is the distribution a standard normal distribution? So remember, it's a normally distributed, and then mean is not 0 and standard deviation is not 1, so it's not standard. It's a normal but not a standard. The answer is no, because a standard normal distribution has the mean 0 and standard deviation 1. Find the area of this region where IQ value is 90, and for the data which is normally distributed with the mean 100 and then standard deviation 50. We can go to this normal distribution calculator, and then we can use the value. Mean is 100 and standard deviation is 15. We would like to find out the value such that less than that value, 90. We would like to find the area under the curve for the less than value 90. So if you hit compute, that will give you the area or probability, which is 0.25 25 if you round it to the 4 decimal place. Okay, 0.2525. This is another question, but very similar question. Instead of less than, this time you need to choose the greater than. The mean is 100 and standard deviation is 15. Very same, but it's a greater than 93. So greater than 93. The area is 0.6796. So if you round it to the 4 decimal place, it's a 0.6796. 0.6796. Okay, we would like to find out for this IQ test from 75 to 110. The mean is 100 and then the standard deviation is 15. Find the area under the curve. Exactly same calculator, but this time between 75 and 110. Mean is 100 and then standard deviation is 15. So calculate the area under the curve. It's 0.6997. So that's the probability or the area, 6997. Okay, here we would like to find out the value of x such that the area under the curve is 0.8. Find the indicated IQ score. The graph of the right depicts IQ score of adults. Again, the same calculator here. It's a standard one, 115. We would like to, we have given the area. We don't have this IQ test value. We need to find this value, the middle one, but we have given the area 80%. So that is 112.62. If you round it to the 1 decimal place, 112.6. That is the IQ level for that 80% area. For 99% to the right, don't forget that. So you have to go back here. It's to the right, and then area is 99% to the right for that value. The value is 65.1. Remember, the mean is 100 and the standard deviation is 15. You would like to find out the value such that anything after that would be the area under the curve after that value is 90%, 99%. So that is 65 point. Let me just double check here. It's a 65.1. Assume that adults have IQ score that are normally distributed. So it's a normally distribution already. The mean is 105 and standard deviation is 20. Find the probability that a randomly selected adult has an IQ less than 137. Go to the same calculator, less than 137. But remember, the mean is different here. It's 105 and then standard deviation is 20. What's the probability that any randomly selected adult has IQ level less than 137? That's 94%. So round it to the 4 decimal places. It's a 0.9452. 0.9452. Because as you can see here, the mean is 105. So 94% of the adults, they have IQ level less than 137. Assume that adults have IQ score that are normally distributed with the mean 100.6 and standard deviation 15.4. Find the probability that a randomly selected adult has an IQ greater than 119.5. So this time it's not less, but this is greater and greater than 119.5, but make sure that the mean is a little different. It's 100.6 and the standard deviation is also different. It's a 15.4. So the probability is less than 11%. So 0.1099. 0.1099. Assume that adults have IQ score that are normally distributed with mean 105 and standard deviation 20. Find the probability that a randomly selected adult has an IQ between. So this is between calculator we need to choose between, and we need to just replace this value 105 and then 20 here. So we need to find the probability between 86 and 124 IQ, which is 65%, more than 65%. So it's a 0.6579. 0.6579. Okay, engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all adults. Accommodating 100% of adults would require very wide seats that would be much too expensive. Assume adults have hip width that are normally distributed with a mean of 13.8 inch and a standard deviation of 0.9 inch. Find P99. That is, find the hip width for adults that are separates the smallest 99% from the largest 100%. So you can go back to the normal distribution and you can just replace the mean by 13.8, and then standard deviation is 0.9. You would like to find the standard one. You would like to find out something, some number which gives you 99% data to the left. 99% data to the left. So as you can see here, this value, which is 15.89 inch, separates the lower 99% to the upper 99, upper 1%. That separates the smallest 99% to the upper 1%. So that is 15.9 inch. 15.9 inch. Okay, let's go to the next question. Question number 21. The length of pregnancy are normally distributed with the mean 269 days and standard deviation 15 days. In a letter to an advice column, a wife claimed to have given birth 309 days after a brief visit from her husband, who was working in another country. Find the probability of pregnancy lasting 309 days or longer. So we can we can solve this type of problem by using the very similar type of calculator here. The mean is 269 days, and then standard deviation is 15 days, and we would like to find out the probability such that the pregnancy days is greater than 309. If you do that, it gives you the probability which is less than, very small number. It's even less than 1%. So the probability that pregnancy will last 309 days or longer is 0.0038. 0.0038. Very rare. What does the result suggest? The result suggests an uncommon but not significant event occurred. The result suggests that either a very rare event occurred or a husband is not the father. Okay, that's the answer. Because the chances of happening this is very, it's less than 1%. Babies who are born on before, so we need to find out the premature babies. So if the length of pregnancy is in the lowest 2%, so lowest 2% means we need to find out the days for which it's lowest 2%. So the area under the curve is 2%, and we need to find out the days. So that is 238.19. So the babies who are born on or before, if you round it to the nearest integer, it's a 238 days. 238 days are considered premature. Okay. Where would a value separating the top 15% from the other values on the graph of a normal distribution be found? So top 15% is the right side of the graph. So the right side of the horizontal scale of the graph. Okay, that's the top 15%. Okay, next question. If you are asked to find the 85th percentile, you are being asked to find an area corresponding to, no, the value or data value associated with an area of the point 85 to its left. A researcher collects a simple random sample of grade point average of a statistics student and she calculates the mean of this sample. Under what condition can the sample mean be treated as a value of population? So remember, if it's the data is coming from the normal distribution, so average grade point average supposed to be normal distribution, or the size of the sample supposed to be greater than 30. So that means the grade point average C collects supposed to be greater than 30. So if the population of a statistics student has a normal distribution, no, the sample has more than 30 grade point averages. That is right. If the population of grade point average has normal distribution. Okay. Annual incomes of a statistics student are known to have a distribution that is skewed to the right instead of being normally distributed. Assume that we collect a random sample of annual income of 50 statistics students. Can the distribution of income in the sample be approximated by a normal distribution because the sample is large? Why or why not? So the answer is yes. The answer is can the distribution of income. The distribution of income is not normally distributed, but the mean is normally distributed. So the answer is no. The sample means will be normally distributed, but the sample of the incomes is not skewed to the right. Assume that female have pulse rate that are normally distributed with the mean of 76 beats per minute and standard deviation is 12.5 beats per minute. If one adult female is randomly selected, find that her pulse rate is less than 83 beats. We can use StatCrunch. One female is selected. Remember, the mean is 76, and because it's a normally distributed, so we can use this normal calculator, and the standard deviation is 12.5. And then we would like to find out what is the probability that the pulse rate is less than 83. So that is 83. Sorry, 83. If you compute that, that's the probability, which is 0.712223. 0.7123. Because it's there is a 6 here, so it's 7123. That's the probability. If you randomly pick one adult female. If you pick 4 adult females, that is sample of 4 adult females. So in this case, it's a you use the same calculator, but keep in mind the mean would be same, but the population would be because of the central limit theorem, you have to divide the standard deviation by square root of sample size, which is in this case 4. Square root of 4 is 2, so you have to divide that by 2. Now you need to find out the probability of getting if 4 adults are randomly selected, find the probability they have pulse rate with a mean less than 83. So less than 83, that is 0.86. So that's more probability. So 0.8686. So that's the probability. The only difference is this time it's a sample mean instead of one person. Why can the normal distribution be used in part B? Because of the original population is normally distributed. That's the one reason. Since the means rate since the original population has a normal distribution, the distribution of sample mean is also normal. Okay, question 27. Assume that amount of weight that male college students gain during their freshman year are normally distributed, with mean is 1.2 kg and standard deviation 5.1 kg. If one male college student is randomly selected, find the probability that he gains between 0 to 3. So we need to use, because it's a normally distributed population, we can use normal distribution calculator, and the mean is 1.2 kg and then standard deviation is 5.1 kg. And then we would like to use between, so between 0 kg to 3 kg, what's the probability? We would like to find out that, and that's 0.23 0.2309. That's the probability. of gaining between 0 to 3 pound. If you select 16 male college students, so that means the sample, you have to divide this standard deviation by square root of 16, which is 4. And now the probability is 7477. 7477. Remember, we are using central limit theorem here because the original the population is normally distributed, so we can use the central limit theorem. There are two situations where we can use the central limit theorem, and we can treat if the original population is normally distributed, then sample can be treated as a normally distributed, and we can use the central limit theorem, or the sample size is greater than 30. So in this case, original population is normally distributed, so we can use that. Why can the normal distribution be used in part B? Because the original population is has a normal distribution. Okay, an elevator has a play card stating that not play card, play card stating that maximum capacity is 3,900 pound, 26 passengers. So 26 adult male passengers can have a mean weight of up to 150 pounds. Assume that weights of the male are normally distributed with a mean of 184 pounds and standard deviation is 36 pounds. Find the probability that one randomly selected adult male has the weight greater than 150 pounds. Go here, use the normal distribution calculator. Mean is given, that's 184 pounds, and then standard deviation is given, which is 36 pounds. Now we would like to find out the probability such that if you choose one male randomly, what's the probability that the weight would be greater than 150? Greater than 150. So the probability is 82%, 83%. 4 decimal place, it's a 0.8275. 0.8275. So more than 83% or 82% chance that that person one person has a weight more than 150 pounds. The probability that a sample 26 randomly selected adults, find the probability that a sample of 26 randomly selected adults male has a mean weight of 150 pounds. So keep in mind, since the original population is normally distributed, so we can use the central limit theorem here. For that, we just have to divide this standard deviation by square root, this is how you type SQRT, square root of 26. And we would like to find out the probability of the sample mean greater than 150 is it's 100% if you round it to the 4 decimal place. So does this elevator appear to be safe? No, because find the does this, no, if the chances of getting more than 150 pound is 100%, then this is not safe. Because more than 50 pound means ultimately for 26 adult the weight would be greater than 3,900. So the answer is no, because 26 randomly selected people will never be under the weight limit. Okay. Oh, did I choose wrong? No, because there is a good chance. Oh, okay, that's my mistake. It's a chance. So we cannot say for sure 100%. That is the statistics. So no, because there is a good chance that 26 randomly selected adult male passenger will exceed the elevator capacity. Fill in the blank. The blank tells us that for a population with any distribution, the distribution of sample means approaches a normal distribution as the sample size increases. The central limit theorem. And the standard deviation of the distribution of sample mean is, this is the formula.